So today we'll be looking at common factoring and factoring simple trinomials. In the previous review lesson, we talked about expanding or multiplying polynomials. So think of common factoring and factoring as the reverse of that, or the opposite of that. So first, with common factoring, we can pull out a common factor. I like to say pulling it out, or you can think of it as dividing out a common factor by dividing each term by the largest number and or variable. So we want to reduce it as much as possible. So as an example here, if we have 7x squared minus 21x. So first I can take a look at the coefficients, 7 and minus 21. The largest number that I can divide those by is 7. Now I also want to take a look at the variables. So I have x squared and x. So the largest variable, and when I say largest, I mean with the largest exponent. The largest exponent for x that I could divide by is just x to the power of 1. But remember, we're not going to have an exponent of 1. I would not be able to divide x by x squared, so 7x is the largest common factor we can have. Alright, so now inside my brackets, everything in the expression is divided by this common factor of 7x. So 7x squared divided by 7x, I'm left with x, and then minus 21x divided by 7x, I'd be left with minus 3. So this is common factoring, this is reduced now, and this is the reverse of the distributive property, because now if we were to take this expression right here, this looks like something we were given before. 7 times x is 7x squared. 7x times minus 3 is minus 21x. So we do in fact have what we started with. The next example, it's a little more complicated, but it's the same idea. So first, let me look for the largest coefficient that I can divide by. So I have 12, 3, and 6 as my coefficients. The largest number that can divide all of those would be 3. Now, I have the variables a and b. Now, all of these terms do have at least one a and one b, so I know that I can divide by ab at least. But what about the exponents? Now, this one has a to the power 5, we have a to the power 3, and we have a squared. So we can divide this by, at the very most, a squared. Anything higher, and this term would not be able to be divided. Now, in terms of the b's, this is b, so that's to the power of 1, b squared, and then another b. So just b to the power of 1 is the highest that that one can go. Alright, so now each term will get divided by 3a squared b. So first 12 divided by 3 is 4. A to the power 5 divided by a squared. Remember, with division we can subtract the exponents, so that'll be a cubed. Now b divided by b leaves you with 1, but we don't have to have multiply by 1 there, so just 4a cubed is what we're left with. So next we have positive 3 divided by 3 is positive 1, but remember, we don't even want a coefficient of 1, so we'll just have plus a cubed divided by a squared is a, b squared divided by b, we're left with b, so plus ab. Lastly, we have plus 6 divided by 3, so plus 2, a squared divided by a squared. Now that would be 1. B divided by b is also 1. So I don't need to show 2 times 1 times 1 because that is just 2. So that's what we're left with when we've common factored. And you can also check what you're left with. There's no common factors that exist within this, so I know that I have fully reduced. Alright, so next we'll take a look at factoring simple trinomials. Now, I call this a simple trinomial if there is no coefficient on x squared, or if that coefficient is just 1. There's a little bit of a shortcut method we could do to factor this. So what we want to do, again, this is the opposite of expanding. So we want to take a trinomial, x squared plus bx plus c, and it should look like the product of two binomials. So x plus a number times x plus a number, or it could be minus a number as well. Okay, so we have to just figure out what those numbers are going to be to go inside each binomial. So here's the trick that we use. Those two numbers have to add to b. b being the middle coefficient, and those two numbers must also multiply to c, which is the final term or the constant term. So as an example here, n squared minus 5n minus 24, I'll need two numbers that multiply to negative 24, and those two numbers must also add to negative 5. Now this takes a little bit of trial and error. You're not going to be able to get it right away, so try out a few numbers that multiply to negative 24, but one hint is that if you're multiplying to a negative number, you know that one number must be positive, and also one number must be negative. That's the only way that you can multiply to a negative number. So some numbers that multiply to negative 24. So if I have 8 and 3, I know that multiplies to positive 24, but I want one of those to be negative. If I said 8 and negative 3, they do in fact multiply to negative 24, but they don't add to negative 5, they would add to positive 5. But if I changed it around, if I put negative 8 and positive 3, that would multiply to negative 24 and also add to negative 5. So those are my two numbers there. I can have n plus 3 times n minus 8 is my factored expression. Now, these two can be flipped, so you can have n minus 8 first or n plus 3 first. It doesn't matter what order they go in. Another example here, so we have k squared minus 3k minus 40. So I need two numbers that multiply to negative 40, and they must also add to negative 3. So we're in the same situation again, where we're multiplying to a negative number. So I know that one number must be positive, one number must be negative. It doesn't matter what order they go in your binomials, but they have to add to negative 3. So again, just through trial and error, always check the multiplication first. There's fewer numbers that multiply to negative 40 than add to negative 3. So check that first, and you will come up with the answer. The two numbers that work are negative 8 and positive 5. So my final answer, I have my equal sign, and then I'll have k plus 5, then k minus 8, and again, those can be in either order. Now, just like I showed you with the common factoring, you can actually go ahead and you can use FOIL, and you can expand this, and you'll know that you're correct if you get what the original expression was. So if you're ever doing a factoring question and you're not quite sure if you got the right answer, you can try expanding it, and if you have what you started with, you know you're correct. Alright, so last example. Now this one's a little bit different than the others. I said that a simple trinomial is only if there's no coefficient on the x squared term. So we do have a coefficient this time, and we also have x cubed. We don't have x squared. So it's not quite the same thing as we did before. But here's a hint. Always try to common factor first. That's why I like to cover it first, because it should always be our first step. All three of these terms can be divided by 2x. So if I divide everything by 2x, I'm left with x squared plus 15x plus 54. So now I'm left with, in the brackets right here, this is a trinomial that I can factor just like we did before, but the only difference is with our final answer, we'll still have this 2x out front. That common factor does not disappear. We're not dividing it and it disappears somewhere. It will remain there for the final answer. So two numbers that multiply to positive 54 and add to positive 15. Now, if you're multiplying to a positive number, you could have two positive numbers that are multiplying, or it could even be two negative numbers. Remember, two negatives multiply to a positive. But because we're also adding to a positive number, we know that both numbers have to be positive. Now, again, a little bit of trial and error here, but I'll just tell you it'll be x plus 9 times x plus 6. Those two numbers multiply to 54 and add to 15. And in our final answer, we also have the 2x.